Determine the poles of fz equal to z square divided by z minus 1 whole square into z plus 2, and we also need to find the residue at each pole. So this is the function given to us. What are the poles? The function is having the pole z equal to 1 of order 2. The power is 2, so I am writing the pole is of order 2. And also z equal to negative 2 is a simple pole. Just take the denominator equal to 0 and get the points. So the function fz is having the pole of order 2 at z equal to 1 and the simple pole at z equal to negative 2. And now we have to find the residue at each pole. So first calculating the residue of fz at z equal to 1. So what is the formula for that? The residue of fz at z equal to a is equal to 1 divided by m minus 1 factorial limit z tending to a m minus 1th derivative of z minus a the power m into fz. This is the formula for calculating the residue at the point z equal to a. So to find the residue of fz at z equal to 1, so replacing this a with 1 and this m with 2, because I am having the power 2 over here for z minus 1. So at z equal to 1, the residue of fz is, so this is 1 divided by 2 minus 1 factorial, limit z tends to 1, d by dz, m minus 1 becomes 2 minus 1, that is 1. So it is d by dz of z minus a the power 2 into fz. So this is d by dz of z minus 1 the power 2 into f of z, that is z square divided by z minus 1 whole square into z plus 2. Cancelling these two and we get 1 divided by 2 minus 1 factorial is 1, and limit z tends to 1, d by dz of z square divided by z plus 2. We need to find the derivative for this. So this is denominator whole square. Writing the denominator first and taking the derivative of the numerator. Then negative sign, writing the numerator and taking the derivative of the denominator with respect to z. So this is limit z tends to 1. This becomes 2z square plus 4z minus z square divided by z plus 2 whole square. That gives 2z square minus z square is z square. So when z is tending to 1, just replace z with 1. We get 1 plus 4 divided by 1 plus 2 whole square, that is equal to 5 divided by 3 square, that is 9. So the residue of fz at z equal to 1 is 5 divided by 9. And now we need to find the residue of fz at the simple pole, that is at z equal to negative 2. The power is 1 over here, right? So the residue becomes limit z tends to negative 2. Just simply write z plus 2 into f of z. That is equal to limit z tends to negative 2, z plus 2 into f of z is z square divided by z minus 1 whole square into z plus 2. So these two cancelled out and we are having, just replacing z with negative 2, we get minus 2 whole square divided by minus 2 minus 1, that is minus 3 whole square. That is equal to 4 divided by 9. So this is the residue of fz at simple pole. For simple pole, the formula is limit z tends to a, z minus a into f of z. Here a is negative 2, right? So just calculate the residue for the simple pole like this. For the power higher than 1, we apply this formula. For the pole having the higher order. Okay, thank you.